reaction is oxidative cleavage of alkynes. Okay, so this oxidative cleavage simply means treating an alkyne with an oxidizing agent, such as strong oxidizing agent, such as KMnO4. So when you treat for terminal and non-terminal alkynes, they give you different products, right? So if it is a terminal alkynes, if the terminal alkyne undergoing this reaction, for example, let's say reacting with KMnO4, most of the times dissolved in acids, right? Strong KMnO4. If the oxidation will give rise to a carboxylic acid. This part of the alkyne will give a carboxylic acid. Then this CH here will be oxidized to CO2. But if it is a non-terminal alkyne undergoing this same reaction, the two sides will oxidize to carboxylic acids. Okay, the two sides will oxidize to carboxylic acids. As simple as this. So at the end of this reaction, you have this. Now, for example, if you are looking at, let's look at ethyne. This is a terminal alkyne now, undergoing this same reaction. Okay, undergoing this same reaction. What happens here is that this part will be oxidized to ethanoic acid. Just add OOH this side, plus then this remaining part here will oxidize to what? CO2. But if it's a non-terminal or internal alkyne, let's say we have something like this, for example, KMnO4 reacting with this. So both sides will oxidize to alkynic acid. So I'll have CH3 COOH plus CH3 COOH. So I have 2 moles of ethanoic acid. So take note, ethanoic acid is also known as acetic acid, in case you see acetic acid. Ethanoic acid is the same thing as acetic acid. So the number 7 reaction I'll talk about now is ozonolysis. Ozonolysis of alkyne. Okay, so ozonolysis of alkyne is also the same thing as this, but the difference lies in their reagent. Is that also? So for example, if you react an alkyne with ozone, you are going to form an ozonide. Okay, so this ozonide, so react it with water, you are going to form a carboxylic alkanoic acid. So the final answer to this reaction is an alkanoic acid. So ozonolysis of an alkyne, that is reacting with ozone and water, will give you an alkanoic acid. Okay, so just like this one also. So if I have, let's say, something like this, and we are reacting with ozone and water, so this reaction will definitely give us ethanoic acid plus another ethanoic acid, because it's going to give us 2 moles. So 2 moles of ethanoic acid is produced. Let me give you another one, for example. Let's say I have CH3, C triple bond C, CH2, CH3. This compound 1, 2, 3, 4, 5. This is pent 2-ine, right? This one is both 2-ine. Okay? So if you carry out this ozonolysis of pent 2-ine, in water, you are definitely going to have, the first one will give you ethanoic acid. The second one will give you, how many carbon is here? 1, 2, 3. So it's going to be propanoic acid. That is CH3, CH2, COOH. So watch how I did it. If you cleave this thing from here, you insert OOH to this side, insert OOH to this side. So you have this and you have this. So the answer to this question is, the first one is ethanoic acid. This second one here is what? Propanoic acid. So our answers there, this one here is ethanoic acid. Why this one here is propanoic Ozonoic acid. So at the end of this reaction, we are going to have this. So these are the few reactions of alkyne. So the next one I would have talked about is polymerization reaction, but I won't talk about it. It's very simple. Polymerization reaction simply means polymerizing an alkyne to a more bigger form of a compound. For example, you can polymerize ethyne at high temperature and pressure and catalyst to give you what? Benzene. So polymerization of ethyne gives you benzene when the right conditions are being met. The catalyst, the pressure, the temperature, all are at optimum conditions that can be able to initiate that reaction to happen. Normally, it is difficult, but when those catalysts are being put in check, the reaction can proceed and give you the required product. Okay, so these are the few reactions to talk about for alkyne. So we are going to look at their synthesis, how we can synthesize these alkynes and alkenes in the next class or in the next video. You're going to see it. So take your time and go through these reactions I've done. Go through them. You will see some of them in your exams because notice that the major reactions involved in these reactions of alkynes.